Independent events. If the outcome of one event does not influence the outcome of the second event. It's pretty vague. Let's just jump into this. We got some stuff that will come up here in a second, but one bag of marbles contains one white, one yellow, two blue, and three orange marbles. So we got a bag of marbles over here with all these different colors in them. A second bag has two white, three yellow, one blue, and two orange marbles. So we've got like one bag over here, and then we've got a second bag over here. Okay. What is the probability of drawing a blue marble from each of the bags? Couple things going on here. Independent events. Yesterday we talked about independent events, and we so I guess it was yesterday. I don't know. What is today? I think it was probability of A and B. We may have written it like that. Equals probability of A times probability of B. Okay. So we multiplied two things here. Had a wise man once tell me, if there are multiple things going on, we're going to multiply. That's not always correct, but in this case it is. We got a bag of marbles over here with all these colors in it. Bag of marbles, all these colors in it. What is the probability of drawing a blue marble from the first bag and from the second bag? So I could have rephrased this as drawing one from the first bag and the second bag. Well, what's the probability of getting one from the first bag? How many total marbles are in the first bag? We've got one, that's two, that would be four, and seven total marbles from the first bag. How many of those are blue? Two of them are blue. Second bag, how many total marbles we got? Two, that's five, six, eight, and how many of those are blue? Just one of them. Multiply. 2 out of 56. I think that's 1 out of 28. Okay, I'll slide over and look at some of these. Courtney flips a coin and gets a heads. The next time she flips it, she gets a tails. So we got a coin, flipped it, heads, flipped it again, tails. What is the probability Courtney will get tails the third time she flips the coin? Does what she got the first two times have any effect on what that coin's going to be that third time? No, it does not. It's going to be 1/2. Some of you might write that as 0.5 or 50%. Moving forward, we're probably going to write it as the fraction. So now the next problem is similar, but it is different, similar. What is the probability that Courtney flips a coin 3 times and gets heads the first time, tails the second time, and tails the third time she flips a coin? And we're going to be multiplying here. So we have multiple events going on. Over here was just one event. It was like, well, what's she going to get the third time? This is, what's the probability that this happens, and this happens, and this happens? So we've got multiple events multiplying here. All right, so what's the probability we get heads the first time? 1/2. Probability we get tails the second time? 1/2. Probability we get tails the third time? 1/2. Multiply those things. If you think that's 1 out of 6, you can't multiply. That's 1 out of 8. 2 times 2 is 4, times 2 is 8. A teacher has 6 red apples, 4 yellow apples, and 2 green apples in a bucket. Because that's what teachers do. They carry apples around with them in a bucket. Maria will choose 2 apples at random, replacing the previous one each time she picks a new one. Let's underline that. Replacing the previous one each time she picks a new one. So Maria's going to take an apple out of this bucket that all teachers apparently have, and she's going to say, wow, that is a red apple. And then she's going to, very creepily put it back in the bucket so the teacher can't see. And then she's going to grab another apple and say, like, wow, that one's green. So we want to know the probability of that happening with all these different colors in there. So replacing it each time. So what's the probability that Maria will choose a red apple and then a green apple? How many total apples we got here? We got 10, 12 total apples here. And how many of those are red apples? 6. Okay, so next time, so she takes it out, puts it back in, and then probability to get a green apple. We still have 12 total apples in there. How many of them are green? 2. That's 12 out of 144. That's 1/12. Next, we've got Dependent events over here. I should say dependent right there. Same kind of rules apply, and you'll kind of see the difference here in a second. It says if one event has an influence on the outcome of the second event. Once we see some examples, you'll kind of see what that means. Notice it still says and right here. We're still going to be multiplying. Tony casts his line into the pond containing 7 catfish, 8 brim, 3 trout, and 6 northern pike. Pause. 1, that's how you spell brim, if you're wondering. 2, what type of pond only has 24 fish and this variety of fish? Come on, math people. Make up a better problem. Tony casts his line into a pond containing 7 catfish, 8 brim, 3 trout, and 6 northern pike. When Tony catches fish, he keeps them. He keeps them. So he catches the fish, takes them out, says, man, look at this fish. It's so big. And then keeps them out of the pond. What is the probability that Tony will catch a brim on the first cast and a second brim on the next time he casts his line? All right, first time. How many total fish we got in this pond? 15, 24? Okay. What's the probability Tony will catch a brim on the first one? There are 8 brim. Okay, so caught the brim, got it out. It's not in the pond anymore. How many total fish are in the pond? 23 now. There was 24, now there's only 23. And a second brim the next time he goes fishing. Well, there's only 7 brim now. Multiply those things, you get 56 out of 552, which will reduce to 7 out of 69. Okay. Russ is pulling 2 socks out of the washing machine in the dark. It contains 3 tan, 1 white, and 2 black socks. If Russ reaches in and pulls out the socks one at a time, what is the probability that he will pull out 2 tan socks on his first 2 tries? There's some problems with this problem too. First of all, why doesn't Russ just cut on the lights? Can't he just, cut on the lights and say, oh yeah, this is a tan sock, this is a white sock? No. Okay. The next problem is the variety of socks. There are only 3 tan. Where's the 4th one? Where's the second white one? I don't know. The next thing is, if he reaches in and pulls out socks one at a time, he's taking them out and he's putting these things on out of the washing machine, not the dryer. He's taking socks out of the washing machine and now he's squishing around in these wet socks like a moron. Thank you for listening. Russ is pulling 2 socks out of the washing machine in the dark. It contains 3 tan, 1 white, and 2 black socks. If Russ reaches in and pulls out the socks one at a time, what is the probability that he will pull out 2 tan socks on his first 2 tries? First try, we've got 6 total socks. And there are 3 tan. Okay, so now Russ, who's in the dark apparently, and he takes out a tan sock and he puts it on his foot and he's squishing around in it. How many total socks are in the washing machine still? 5. How many of those are tan now? 2. That's 6 out of 30. That's 1/5. A teacher has 6 red apples, 4 yellow apples, and 2 green apples in a bucket. Maria will choose 2 apples at random without replacement. So same exact problem as up here, except Maria is not replacing them. Thief, Maria. Okay, so we got the teacher walking around with all the apples in a bucket like a weirdo, and then Maria the thief is walking behind the teacher and stealing her apples and not replacing them. What is the probability that Maria will choose a red apple and then a green apple? How many total apples we got in the bucket? 12. And how many of those are red? 6. Okay, Maria, the weird thief that steals apples from the teacher's bucket, is not replacing them. So now there's only 11. How many of those are green? 2 of them are green. 12 out of 132, which is 1 out of 11. Next style, we've got some extra probability practice. A code consists of a digit chosen from 0 to 9, followed by a letter of the alphabet. What is the probability? The code is 9Z. Okay, so we're choosing a number, and then a letter. How many digits are there? If you said 9, you're wrong. There are 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability we get a 9 on the first one is 1 out of 10. How many letters are there in the English alphabet? 26. If you didn't know that, you should know that. All right, let's multiply. 1 out of 260. That's your answer. Okay. Next, a code consists of a 2-digit number chosen from 00 to 99, followed by 2 different letters. Different is an extremely important word right here. Underline that. Different letters of the alphabet. What is the probability? The code is 1, 2, K, Y. I've got 4 different things here. And what's the probability I'll get a 1? That would be 1 out of 10. What's the probability I get a 2? 1 out of 10. What's the probability I get a K? 1 out of 26. And then the word different shows up. This last one can't be a K. So I have to go down by 1 because my options have gone down by 1. Different. We're going to keep subtracting 1. If it had said 1, 2, K, Y, A, then I would have said 1 out of 26, 1 out of 25, 1 out of 24. Because they have to be different letters. If it said different digits, if up here it said it consists of a 2-digit number that the digits have to be different, it would be 1 out of 10, 1 out of 9. Okay, it didn't say different digits, so it's 1 out of 10, 1 out of 10. When you multiply this, you get 1 out of 65,000. Last set. You write each of the letters of the word Mississippi on pieces of paper and place them in a bag. Just seems like a really weird thing to do. Write all the letters of Mississippi on pieces of paper and place them into a bag. If you get bored today, enjoy and see what the probability is. You randomly draw one letter. Do not replace it. So you're like Maria the thief. One, you're weird because you're putting pieces of paper with all the letters of Mississippi on it in a bag and drawing them out one by one, but then you're not replacing them. Okay, and then you're going to draw a second letter. What's the probability that the first letter drawn is an I? Well, how many total letters are in the word Mississippi? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total letters. How many of those are I's? 4 I's. Okay, did not replace it. That means there's only 10 in there now for the second draw. And the second letter is an N. There's only one N. That would be 4 out of 110 or 2 out of 55. You write each of the letters of the word Mississippi on pieces of paper and place them in a bag. You randomly draw one letter, replace it, then randomly draw a second letter. What is the probability that the first letter drawn is a P? So we still have 11 letters. How many P's are there? There's 2. Okay, we replaced it, so there's still 11 letters in there. And then how many of those are I's? There are 4 I's. That is 8 out of 121.